For this problem, we're going to be looking at a calculation where we find the average atomic mass for a particular element. So we've come up with a hypothetical element here. It's not told to us, but it gives us a distribution, an isotopic distribution of, the element. And remember, all elements have different isotopes. There may be a few that have just one, or maybe a predominance of one, but there's many that have some small percentage of a less favored isotope. And we can have radioactive isotopes. Of course, those are going to be degrading over time. That's why they're called radioactive. But let's just consider, if we have a mound of some particular element, let's just remember that in that mound of element, which we know is made up of only one type of atom, that one type of atom can be different from another that's exactly the same atom. How? We said neutrons. Those neutrons can be differing within the nucleus of a sodium atom, and another sodium atom has a different number of neutrons. That's natural. That was not thought by John Dalton, of course. He thought all atoms of sodium would be the same, but we know that's not the case. Let's go ahead and quantify then. If we had a pile of a particular element, how do we find the average atomic mass? Even though it's just a mixture, we still have to deal with an average atomic mass. So they've given us the distribution. It's 90.84% of this weight, 19.9924 atomic mass units. So as we read atomic mass units, we're going to be able to convert that to moles and say this represents grams. So when we see AMU, we're often going to think grams per mole. 1% of this pile of whatever element, it doesn't tell us what that element is, 1% of it has this weight. The atoms that, divvied up, this isotope, this isotope, this isotope, they differ in weight, of course, because of those neutrons. 20.9940 AMU. And then last 8.16% has this weight, 21.9914 AMU. It's just almost cut off there. So let's set up, and we want to remember maybe before we get started that we're going to have two parts to this calculation. You're going to have a multiplication that you're going to have to do. And then you also have to have an addition of all of these together. So we're going to do those in two parts. So I'm not going to color code the math, but it's not application, addition. We're going to have two parts. And we're going to watch the sig figs as we go. But remember, we keep sig figs as much as possible until the very end. So I'm going to set this up where I bring these two underneath this one. So we're going to bring these two over, and we're going to change it into fractions, from percentage to fractions. So let's do this 0.9084, put a 0 out front, times 19.9924. And I'm going to go ahead and lose the unit here just for now. We'd also then say plus 1%. Now changing that to a fraction, remember we move the decimal point 2 places. So changing it from a percentage to a fraction, we move it 2 places. So we'd say 0.0100. We're going to keep those sig figs. It gave us those. We're going to keep those. Here I had 4, here I have 3. That's times 20.9940. And last but not least, we have our last one, 0.0816 times 21.9914. So what we're going to do is go ahead and set this up where we put this number, what we get as a multiplication, we're going to put it here. So I'll rewrite this over here so that we have the sum of this multiplication and the sum of this one, the sum of this one. Okay, so 0.9084 times 19.9924 is equal to our 18.16. We're going to keep all the figures, 109616. The next one, 0.01, just for sake of ease, I'm going to just leave it there, times 20.9940 is equal to 0.20994. And then last, 0.0816 times 21 point, right? Yeah, 21.9914. We get 1.79449824. Check that to make sure. Yeah. Okay. So now what we want to do is consider the sig figs. And remember, in multiplication, it's all about numbers of sig figs. It's not about placeholders. So we'd say for this one we have 4, and this one we have a lot. Of course, I'm just going to not look at this side. 4. So we would underline after the multiplication. We'd say I have that number of sig figs if we were to stop here. For this one it's 3, so I'd say there, and for this one it's 3. 1, 2, 3. This 0 is a leading 0. So we can see that we have now going into addition, going into this addition where we add these, we're going to be looking at that hundredths place, not the tenths place, but the hundredths place. And we're going to go ahead and combine all of these. So we're going to add that together, but we're going to cut at the very end so that we get back to the hundredths place. So I'm going to take that value that we had here and add to it 0.20994 plus 18.16109616 equals, if I do all this, the addition, I would get 20.1655344, and I'm going to go back to underlining because of now place value. I'm not thinking multiplication, I'm thinking addition. It was all about place value, and I had to go to the hundredths place because this one and this one only has sig figs out to that point. This one had it out to the thousandths place. So I'm going to cut back to this digit here. So of course if I do that, we see that it bumps up to 20.17 AMU, and we'll put that unit back in. I hope that helps. Remember your sig figs, just carry them all the way. Carry it all the way to the end, and then deal with it. Then apply your rules. Thanks, hope that helps. Bye-bye.